Good evening, everybody. Today I will be showing you the process on how I created the logic circuit for the adder and subtractor using the components present in Logisim. I will be showing you how I created the half adder, the full adder, the half subtractor, and the full subtractor. So when we start off, so here is the half adder circuit. So we have two inputs, A and B, an XOR, an XOR, yes, an XOR gate, and an AND gate that leads to the carry and the XOR leads to the sum. So you might be thinking, um, what is this circuit I have here? Well, this circuit right here is just the same as I presented you right here. So the output of the truth table will be the same when I analyze this circuit, and the output of the sum in the sum of products will still be the same as these expressions presented here. So now when we go here, I will now show you the process on how I created the half adder, which is very basic. Again, we are just going to take two inputs, label them A and B, take an XOR gate, and then we take an AND gate, both of them having two inputs. We align both of the inputs to the nodes, and then the outputs of each will be assigned to A, sum, and carry. So that's basically how you create the circuit. So now, when we analyze the circuit, as you can see here, we have 0 for A and 0 for B, which have a sum of, which will have a sum of 0 and a carry of 0. And the 0, 1 for A and B will have a sum of 1 and a carry of 0, or 1, 0 for A and B will have a sum of 1 and a carry of 0. And the A and B 1, 1 will have a sum of 0 and a carry of 1, which is the same as we have here in this truth table. And um, for the outputs, so here in the sum, we had the expression of A bar and B, A bar B ended with A B bar. So that's it. For the carry, we only have A and B. So next is the full adder. Now, the full adder, this circuit, now it might seem complicated, but actually it is just two half adders added together. As well, it's in the name since it's full. The other one is half, the other one is full. So for this circuit, we only need to take a half adder. There we go. And take another half adder. Um, Erase the outputs. Create a new add a new input. Label it C in. Connect this one here. Connect the C input here. There we go. And we take another OR gate. Well, not another, a new OR gate. Attach it here. Align it to the carry. And then for this output here, we attach it here. So that is how you make a full adder for the circuit. So let's just erase that. And now we analyze the circuit. We will see that we have a truth table here. So this truth table, wait, let me show it here. So this truth table, for the combinational analysis, we can see that it is the same as what we got here. So three zeros that have a sum and carry of 0, 0, so on and so forth. For the sum of products, we have here A, B, and C in A bar, B bar, C input ended with A bar, B, C input bar ended with A, B bar, C input bar ended with A, B, and C input. And for the carry, we have the same as well, which we have A B and C input ANDed with A and C input ANDed with an AB. So next now we have the hub subtractor. So for the hub subtractor, um, we can also see that from here it was just um, simplified with this. So the only difference between the two circuits is that we have a NOT gate attached to the attached as an input for the AND gate. So in order to create this, again, I will show the process. We only need two inputs, A and B, label them. Copy. I just copy the components since it is easier to um, it is faster. So now we're going to attach the inputs for B and the inputs for A here. Oops. There you go. And now these two will produce an output for the difference and the borrow. There you go. That's how you create the half subtractor. So now when we analyze the circuit, there you go. When we analyze the circuit, um, we can see that the truth table is the same as what we have here. So, and then for the sum of products, we have an A bar B ANDed with A and B bar. And then for the borrow, we have an A bar and A bar B, which is just cut off. And now, next is the full subtractor. Now you might be thinking, how do we make the full subtractor? Again, it's just like the same process for the full adder, except we are going to be using the half subtractor. So here we go. Here is here is it. And then we are going here. I will just copy the full subtractor, the half subtractor, I'm sorry. Copy it twice. Erase these. Go. Create a new input. Label it B input. Attach it here. Again, it's just the same process as we did to the full adder. So, oops. What we're gonna do here, for the borrow. Well, now this is going to be a B out. Well, actually, it was B out to begin with. And then attach this here. So now we have a full subtractor. Let's just erase that. And then we analyze the circuit. Again, we will compare it with the tables that we have here. So, as you can see, we have the same table as the same table in the circuit. So, we go to the sum of products. We have A bar B input ANDed with A bar B input bar ANDed with A B input bar ANDed with A B input. And then for the B out, it's A bar B input ANDed with A bar B ANDed with B bin. So that is essentially the adder and subtractor circuits in laboratory activity 3. So that ends my presentation. Thank you.